So I'd like to welcome everyone to today's SWANA e-learning event. Everyone should be seeing a slide with the title of today's webinar on it, as well as a list of some of our upcoming online events. Before we begin, I would like to let you know about two e-course opportunities offered by SWANA. The first one is the Transfer Station Systems e-Series. This deals with how to effectively communicate and overcome the challenges in planning and operating a transfer station and how the planning and design impact construction and operation. This e-learning opportunity is sponsored by Caring Compactor, recognized as an industry leader in compactor technology. Also sponsored by Caring Compactor is SWANA's Manager of Landfill Operations e-course, available in full as a recorded webinar. MOLO examines best practices and industry standards in landfill management and operations. A few tips about how to use the webinar platform that we'll be on today. First, you may download a copy of today's presentation slides by selecting the file you see at the bottom of your screen and then pressing the Download Files button. To send a message during the presentation or afterwards during the Q&A, you can use the chat box on the right-hand side of your screen to type those in. The Participants box will show you who is on today's SWANA webinar. And to indicate you'd like the speaker to be louder or to speak more slowly, you can use the raise hand icon at the top of the screen and choose the appropriate option from the drop-down menu. There will be time for Q&A after today's presentation. Our today is J. Roy Murray. Mr. Murray is a civil engineering graduate of Texas A&M University and has over 28 years of experience in civil and environmental permitting, design, and construction. This includes work on municipal solid waste landfills and associated systems, liner systems, leachate collection systems, utilities, roadways, hydrologic analysis, and hydraulic design. Mr. Murray also has extensive experience in landfill design, operation, and construction, having served for 2 decades as a consultant preparing landfill expansion permit applications. He has served as the certifying engineer for dozens of landfill liners, final cover systems, and waste ponds, and has also served as site engineer for a major private waste company. His responsibilities included project management of permit amendments and modifications, compliance, and construction management. With that, I would like to turn things over to Mr. Murray for his presentation today. Are you ready?
I'm ready.
Wonderful.
Thank you, Jesse. Well, I appreciate everybody being here today. Let's see if I can get this presentation to work the way it is. Today what I'm hoping to do is provide you with the understanding of how and where leachate evaporation ponds are useful, how to design them, and ultimately how much they cost. The timing of this presentation is a bit fortuitous, almost by chance, given the EREF meetings that are going to be and presentations that are going to be taking place in Austin over the next couple of days. And with that, we'll start. What are the landfill leachate handling and disposal options? Wait a minute. Where is my...
The lower left hand of your screen.
There we go. Thank you.
Perfect.
Typical leachate disposal and handling options: recirculation, on-site treatment, off-site POTW, mechanical evaporation. I didn't include a picture of a leachate evaporation because they don't tend to make very good pictures. But today what we're going to be talking about specifically are leachate evaporation ponds. These ponds very basically are lined ponds for the storage and evaporative disposal of leachate. A lot of people can use these to basically provide a buffer, a storage pond while they're getting rid of their leachate through other means, and they maybe can take advantage of some net evaporation over the long haul. In this picture of this particular facility, just on a completely unrelated side note, if you look in the upper left-hand corner, the upper right-hand corner, you'll see a dark straight line that goes across, and that dark straight line is the border fence. The tree line in the background is actually the Rio Grande River, and that's the famous border fence. You'll notice it only goes about 1/3 of the way across the page. So anyway, enough of that. Typical leachate evaporation ponds. You'll see singular ponds, multiple ponds, aerated ponds, and non-aerated ponds. And today we'll be looking at the aspects of any of those. Where are leachate evaporation ponds practical? Well, it makes sense. They're going to work on areas where your net evaporation is going to be greater than your precipitation. Here's a picture. This is a leachate evaporation pond in an arid location. This one happens to be in El Salvador. Very arid. They get a lot more evaporation than precipitation, and so they're able to get rid of all their leachate just through evaporation. This is another facility that is only several hundred miles away, but it's in Costa Rica in a tropical location. In this case, they get a little bit of evaporation. They have also added in evaporators into this, and they primarily this serves as more of a holding tank, and they get to get rid of some of the leachate through evaporation. There's different types of evaporation. The National Weather Service tracks evaporation across the United States, and the way they measure it is they determine the pan evaporation. It's using a device like you see here. It's a 4-foot diameter container, and it sits above the ground. You monitor the wind, the temperature, the rainfall, and then ultimately every day how much evaporation has been taken from that pan. Obviously, this is going to give you a good idea of what evaporation is like at your location, but it may not necessarily reflect what the evaporation is going to be like from a pond or from another facility, since obviously this pan is going to be somewhat unique. So there are ways for us to then take this pan evaporation that the National Weather Service has and convert it. There's two other different types of commonly referred to evaporation. The first, obviously, is lake evaporation. You're looking at cooler, deeper bodies of water, typically. The second, and the one we're going to look at for this, is the free water surface evaporation. Free water surface evaporation typically applies to smaller ponds and marshes and man-made impoundments such as water reservoirs and sewage lagoons, and in this case evaporation ponds. So that's what we're going to be looking for. So in computing pan to lake evaporation, you can get from the National Weather Service pan evaporation rates, and you can also get lake evaporation coefficients from them for different periods of time. Ratios for lake pan to lake evaporation range from 0.65 to 0.85. One thing that they do note is that when the water and air temperatures are approximately equal, that ratio is about 0.7. And then on pan to free water evaporation, it's the same equation. You're simply multiplying your pan evaporation by your pan to free water coefficient. Your ratios range from 0.64 to 0.88, but there's an average of 0.7, which happens to goes back to correspond to that earlier pan to lake evaporation of 0.7 when the air and water temperatures are approximately equal. And that's what you're probably very likely to see in a shallower pond like we're typically going to be talking about on these leachate evaporation ponds. So this is a map of the U.S., the pan evaporation rates across the United States. is available from the National Weather Service, and I forget this was I forget the exact number of years, but this was, I think, well over 40 years of information. And here is the annual U.S. precipitation map for in inches per year, and obviously it's a lot more convoluted there. So we take this evaporation versus precipitation and compare it to compare the two, and you'll see these areas in red. These areas in red have basically a zero net evaporation. The evaporation is either going to be the same as or less than the precipitation. So if you were to build a pond, you know, on your average year, you'd either be just holding the same amount of water, or more than likely you'd be collecting more water than you're actually getting rid of. These areas in yellow, they represent basically 0 to 10 inches of net evaporation. So while you technically could evaporate some, if you have a couple of wet years or particularly wet year, it's probably going to be a little bit more difficult to be doing anything much more than storage. But in the rest of the country, you can get anywhere from 10 to 135 inches of net evaporation. So that's the area where the blue area is going to be the areas where you can really take advantage of the leachate evaporation ponds. For my example today, we're going to be using Texas. These are just two maps. One of them is showing the annual evaporation or annual rainfall is on the left, and on the right is the annual evaporation. And this is different because what they've done from the Texas Water Development Board is they have taken the TAN evaporation that the National Weather Service reports and then converted it to lake evaporation based on additional information National Weather Service reports. So this, you're going to be able to compare these two numbers and get what would be your net evaporation. This is the site that I'm going to be using today for an example. It's a landfill in Brownsville, Texas, the southern tip of Texas. You can see the outline in red is the entire landfill facility. And then down in the lower right-hand corner in blue is the leachate evaporation ponds. These ponds are about 2 acres in size, so about an acre each. They're connected by a weir. On the just below the ponds is a landfill flare system, and the condensate from the landfill gas system is dumped into that lower pond, and that's why that lower pond has a reddish appearance. I'm not exactly sure what has caused that. And you can only see it from the high altitude aerial photographs. If you're just looking at the ground, from ground level or from the adjacent landfill, it just looks like water. You don't notice the red hue. And you also notice that just up and to the right of the top pond that you see some pickup trucks there. They were in the process of doing a groundwater monitoring event when this aerial photograph was taken. So, to size your leachate evaporation pond, you're going to need to get precipitation data. In this case, we got it from the Texas Water Development Board. Oh, excuse me one second. So what can we expect to evaporate? The net evaporation is going to be that gap between your precipitation and your evaporation. It's going to average out, but in any one year, in this particular year we looked at 1980, we would have evaporated 40 inches more of liquid than we got in rainfall. So the annual evaporation, we were able to get for that quadrangle, the evaporation over 60 years, and the annual evaporation was 61.31 inches, and that's in lake evaporation, which is more similar to what we expect than the pan evaporation rates if we'd use those. The pan evaporation rates around there were about 100, 105 inches, I believe. So the average annual rainfall, the site gets about, as you can see, it's down there on the southern tip of Texas, it gets about 26 inches of rain a year. Once again, we got this information from the Texas Water Development Board, which is National Weather Service information, and the average over the 74 years was 26.12 inches. So our net evaporation is very simply the annual evaporation minus your annual precipitation. In this case, we end up with about 3 feet of liquid that we can evaporate out of those ponds in any given year. So to look at designing the ponds, we're going to look at how much water the ponds can hold within their operating range and how much we expect to evaporate out of there, and that would give us a total capacity for those ponds over the year, with the idea that you can put so much in there, but as over the course of the year, as you're putting it in there, it's evaporating. So we'll look at the total operating capacity of these ponds. What we did is we went to the help model for the landfills. We figured out that we had an average drainage collected off of the leachate collection system of 3,500 cubic feet per acre per year. The site has a leachate collection system over about 55 acres. You multiply those two together, and you get an annual leachate, in this case I say capacity, but production, expected production of about 195,000 cubic feet. So the pond storage, we're looking at the 2-acre pond storage hold about 285 cubic feet of leachate, and the pond area is 60,000 square feet. So we multiplied that area times the annual evaporation of 2.93 feet, and we would expect to evaporate on your average year 177,000 cubic feet of leachate. So if we add that annual capacity of that pond storage volume of 285,000 cubic feet to the evaporative capability of 177,000 feet, we figure we can handle with that pond over 460,000 cubic feet a year. So our net carrier over, we've got annual evaporation, and we're producing of 177,000 cubic feet, and we're producing 194,000 cubic feet, means that we're going to have to hold 17,000 cubic feet, or 132,000 gallons that would be in that pond. So the 17,000 cubic feet, we would be able to store probably 15 years worth of leachate in there before we reached its maximum operating capacity. I will note that these leachate ponds have been in working out at this site for about 10 years, and typically they only have a foot to 6 inches of water in them. And they've had a couple of tropical storms and hurricanes come through the area, and there have been times when they were 3/4 or more full, but they've been able to, just through time and wind and weather, continue to dry up. And I think right now there may be a half foot of water in both those ponds. So when we're designing the ponds, we look at several things, and one of them is how much storage do we need, and then you want to make sure that we have enough of a freeboard that we can contain a rainfall event or a sudden catastrophic type of event, rainfall event. So what we did, we looked at a couple of things. First, we looked at the 100-year, 24-hour rainfall event. In this case, it's just about a foot. But we also considered, because the site is located very close to the Gulf of Mexico, we wanted to see what might happen if there was a hurricane. So we went back through 74 years of precipitation data to find the month with the single largest monthly rainfall recorded. And in this case, we figured out it was 19.44 inches. It was in September, and that is, happens to be the peak of the Atlantic Gulf hurricane season. So in this case, we were using 19.44. We compared the 100-year, and then we looked at the maximum historical monthly rainfall of 19.44 and decided to use 2 feet. And part of the reason this is important is, in the case of these ponds, we're not building secondary containment. So if there is some sort of event that would cause the ponds to overtop, you would have a leachate release. So we wanted to make sure that we're doing everything we could to ensure that even in a unique event, that we would have enough freeboard in there, as long as the ponds operated correctly, that we don't have to worry about having a leachate release event. General pond layout. If you have room, breaking them into 2 or multiple ponds is good, because it can provide containment if there's a need to repair one side or the other. So if you have an issue in one side, you can pump the leachate into the other side, continue to shut off leachate going into that side, and work to repair it. Otherwise, if you just have a single containment pond and you have a leak or something you have to repair, then you totally have to discontinue using the ponds altogether. In this case, in Brownsville, we divided it into 2 ponds. As you can see, in the middle of it, we have a berm, and then we placed a weir in that berm. That weir allows for the water, the leachate, should it build up on one side before the other, to flow into the other pond while you're without you having to do anything. So in this case, where we have the landfill gas condensate that is going into the southern pond, should that get to be so much that the liquid level in that first pond gets higher than the other one, then it would spill over into the other pond prior to getting to your maximum operating level. In this case, we have the maximum operating level that was 2 feet below the top of the berms, so we set our pond overflow weir at 3 feet below the top of the berms, so that you have a foot difference in there, and any liquid that would build up on the one side would then just simply flow over the weir into the other side. Bottom slope. There are advantages to having the bottom sloped or not. The Brownsville ponds are flat. There is no slope on the bottom, and you could see that in one of the ponds. You could see the area that was there was a little bit of leachate in there, and then you could see dry spots on the floor. But if you do have a pond, a slope on the pond, you can grade in a sump that will allow you to pump out that whole pond much easier. Otherwise, you're going to have to pump out the pond, and you'll get down to 6 inches or a foot or whatever your pump is good to, and then you're going to have to hope that you can evaporate the rest. So you have to look at your climatic conditions, I think, at the time and location of where you're putting this. And if you're in an area where you get really great evaporation, then you can probably get away without sloping the pond's bottom. If you are in an area where your pond is working almost as much as a holding pond as it is an evaporation pond, then you may want to consider putting a slope and a sump in there so you can really get it pumped out. And of course, the big disadvantage to having a bottom slope is just that it takes up storage space. This is an example of a pond that we designed. The client basically told us, we want 1 million gallons of storage. All those calculations that I just detailed, they didn't need any of those. The client came to me and said, I want 1 million gallons of storage, and we designed a pond in the area where he wanted it with 1 million gallons of storage. This detail actually shows you, if you look at the pond bottom, you can see that it slopes to the upper left-hand corner at a 1% slope, and there's a small sump that's been graded into that upper corner on the floor where they could drop it's about a foot deep sump, and they could put a pump in there and pump it all out if they ever needed to clean anything. This is a pond where, once again, all those calculations weren't needed. The site had very little room for to place a leachate evaporation pond, and so they just said, give me the largest pond we can get that we can fit in there. So here we go. We have the perimeter road, the landfill's on the other side of the perimeter road. We've got a drainage feature that we have to avoid, and we've got a 100-year floodplain that we've got to keep it out of. So that sometimes all those calculations I went through can go right out the window, and you're just trying to get as much, in this case, storage and evaporative capability as the site allows. This pond also has a 1% slope towards the upper left-hand corner again, and that sump that you can see there. The liner, standard what we use is just the typical subtitle D liner plus a second geomembrane. Generally what we've been using is textured geomembrane. You don't have to use textured geomembrane on the top as a top layer if you've got a particularly twisted sense of humor and want to watch people slide down it, but otherwise that's what we use. Alternate liner, which is what we utilized at the Brownsville landfill because they were approved for a geosynthetic clay liner, so we use that instead of the 2 feet of compacted clay, and then the 60 mil smooth, and then the 60 mil textured HDPE. These are just details of those liners showing the 2 layers of 60 mil HDPE geomembrane, the 2 feet of recompacted clay with hydraulic conductivity of less than 1 times 10 to the minus 7 centimeters per second, and the subgrade. All these liners are for facilities that are, in this case, located inside of the landfill groundwater monitoring system. If you do have one outside, then you may have to put in a leak detection layer. As far as the life of these exposed geomembranes, both HDPE and LLDPE are currently being tested and have been being tested for 28 years, and all they know right now is they have a life of greater than 28 years. I got this information from a article from 2008, but 28 years is certainly, it's going to be somewhere north of that. So this is a typical perimeter section. It is very similar to what you would use on just your landfill liner details. But the important thing to note here is you need to make sure that your berm is more than high enough to keep any storm waters that might be around there from flowing into there. You don't want to accidentally have a nearby ditch overflow or something and then it cause a bunch of just regular storm water to go into your ponds. So I make sure that the pond is designed to have the edges of that be the highest thing around. Just a second, I'm looking at some questions that have come up. On the leak detection, we're going to get to that in a second. And how is dredging accomplished when the pond is lined? I'll probably look for a little bit more info on what you're looking for in that question in here in a little bit. I will say, if you're asking, that in the case of this particular instance, the facility is located in a area where it's very dusty, it's very windy, and the pond has been there for operating continuously with lots of leachate for over 10 years, and I would guess that there might be a quarter to a half inch of sediment in the bottom of those ponds. It's not much more than that. And if you're going to remove that sediment, it would have to be done manually, probably with some flat shovels. On the leak detection, basically what you would do with the leak detection is place a double-sided geocomposite below the two layers of HDPE and above your soil liner component, and that would obviously detect any leakage that's coming through the two geomembranes. We've had to do this, but we've typically had to do this when the evaporation pond was located outside of the landfill's groundwater monitoring system. This is just a detail of the sump. You're simply building something that's very similar to a landfill sump. It's just underneath the geomembrane. You've got a riser pipe and some perforated pipe and gravel, and that's that. This is a pond with a leak detection system, and in order to have it to minimize the airspace loss because of the pond slope having to go all the way up to one end, what we did was we split it and put in two different sumps, so that cut down the airspace or the capacity loss on both of those. And for this particular pond, designed it to be one of a series of ponds. So when they build the next pond, as the landfill develops, they're going to build it next to this and adjacent to it, and they're going to cut in the weir like we discussed earlier, so that um, so that they could have the overflow between the two ponds, and then they can have additional capacity as they move on. Aeration or non-aeration. The pros of aeration are it does increase the evaporation. How much it increases the evaporation is going to depend on the aerator you're putting in there, and how many aerators you have, and so that can be difficult to evaluate. But I do know there are a lot of sites that like to use it, and it can also help control odors. I have seen some ponds that did have odors. This one in Brownsville, they've not had any issues with it. Several of the other ones that I'm familiar with don't have odors, but they also have evaporation, or they also have aerators. The downside of that is that, one, it costs money to purchase the aerators, to install them, and then you're constantly you have the electrical and maintenance costs. Another thing is, depending on the type of aerator, if you're really getting the mist up into the air, you can have issues where I've heard of people then all of a sudden the water that was had the odor issues was then blowing in mist across in the areas where you maybe offsite or were taking the odors elsewhere. So you've got to look at that when you're determining what kind of aerators you want and whether or not you need to do that or not. In the case of Brownsville, they've been able to get by without it. There was some initial talk, should we get aerators? And my recommendation was that they wait and see if they couldn't keep up with the evaporation, or if they started having odor issues. I said, let's wait, let's give it some time, see how the system operates. We can always put aerators in, and a decade into it, and they haven't needed to have it yet. These are different types of aerators. The one in the upper left-hand corner you see, that's one where you can really have, obviously, issues with that mist getting off-site. Then you've got different bubbler aerators and stirring aerators, and how much they evaporate is really going to depend on the location of and the type of aerators that you're getting. Another thing that is useful, I don't have any numbers on it, is you can increase your evaporation by putting in these weep pipes, where you're basically taking the leachate that's getting pumped into the leachate evaporation pond, and you're having it just at different locations. Say in this case, I think they're about every 30 or 40 feet apart, just being sprinkled or weeped onto that black plastic. If the idea that especially during the hot summer months, that you're going to get some evaporation that's going to be coming off that hot black plastic, and could help increase your evaporation. So the cost for these typically run anywhere from $70,000 to $90,000 an acre, and this includes dirt work, your excavation, your structural fill, your liner, your recompacted clay or geosynthetic liner construction, your primary and secondary geomembranes, leak detection layer, vegetation of outer slopes, and aeration. The Brownsville ponds, they cost about it was about $140,000, so it was $70,000 an acre, but they're very basic, so they would be on the low end of what it costs for that. So the cost per gallon for disposing of leachate in a site like this is about a half a penny, and that assumes that the evaporation ponds only have a 20-year life. So if you take all the leachate that they're going to dispose of over that 20 years, and the truth is, these ponds could have, as we saw earlier, they could have a 28-plus year life. So assuming a 20-year life, you're looking at about a half a penny a gallon to dispose of leachate. And these are the various references I had for a lot of the numbers and whatnot you saw in the presentation. And with that, I will thank you for attending, and I'll open the floor to any questions.
Thank you. Oh, sorry. Thank you so much. Just wanted to let everyone know they can ask their questions in the chat box.
Looking at going back to the question about how is dredging accomplished when the pond is lined, and wouldn't that compromise the integrity of the composite liner? What you would do is simply just go in and take off the top whatever sediment is accumulated. And I've never seen a pond where there were significant amounts of sediment that had accumulated that you couldn't handle that basically just manually, with people walking on that liner and using say flattened shovels, maybe even plastic shovels, brooms, whatnot, that I've seen employed when people have had to clean soil off of landfill liners and whatnot. So as long as people are being careful, and it can certainly be cleaned easily without compromising the liner. Wave action from high winds. I don't think in the case of these ponds, the fetch, the length across the open part of the pond, is not going to be sufficient to generate much in the way of a wave. Now, if you're in a location where that's just a really unique condition, well, I would certainly go in and calculate that. So yeah, I guess the answer would be yes. I don't think on average the typical designer would need to worry about that. But if you're in a location where you have uniquely high winds, that could be something you'd want to look at. Okay. Have I ever seen any UV degradation of the liner? No. No, we haven't noticed any of it yet. Like I said, the pond has been out there for 10 years, and we've had really no issues. The liner, other than being dirty, looks just as strong as it did when it went in. And I also know other facilities where they've been using 60 mil HDPE as rundown channels off the top of the landfill, and those have shown no signs of degradation that I've seen. For less arid states, how practical would it be to put a roof over a cover to shed rainwater? And a lot of people have said that or asked that question. And the problem is, how do you shed the rainwater without then putting the entire pond in shade, which would significantly reduce the evaporation? And so I have not seen a instance where anybody's really tried to do that and still be able to evaporate leachate, or at least have it be anything much more than a holding pond.
And it looks like we have other questions coming in the chat box. I just wanted to remind everyone that a copy of the recording from today's webinar will go out later this afternoon.
Is there a way to calculate evaporation of a covered pond? Not that I'm aware of. Everything that I've seen has all been about evaporations of non-covered ponds, which makes it for those areas where you don't have a good net evaporation, it makes it a pretty. It can be a pretty difficult to get it to work. In fact, you can have one or two wetter than normal years, and all of a sudden you've put yourself in a bad way, and you're having to get rid of more leachate than you might have to.
While we're waiting for additional questions, I'd like to encourage everyone to please complete the short survey that will appear on your screen after today's webinar is completed. Your feedback is very important to us and allows us to give you the best webinars possible. And it looks like another question's come in.
Okay, slide 15. Did I use the free surface evaporation and precipitation or pan evaporation and precipitation for the chart? I'm trying to figure out which one's slide 15. Oh, I think I know which one. Well, I'm trying to get to that slide. Okay, that is a pan evaporation. So, yeah, so on that chart I use pan evaporation, so that's why I initially went in and highlighted the yellow area, these red areas. Those were simple basic evaporation versus pan evaporation. And then I took out the 0 to 10 instead of just as, okay, if I'm going to convert this to a lake evaporation or a free water evaporation, those areas are probably going to come out of there. So basically anything in the yellow, by the time you probably convert it from a pan evaporation to a lake or a free water evaporation, it's probably going to be upside down. Let's see. How should groundwater well network around leachate pond to monitor any seepage? Well, in this case, we located you would want to locate the ponds such that if there was any leakage from there, your groundwater monitoring system was installed and operated sufficiently to pick that up, just like it would a landfill. So if obviously if you positioned it where a leak from that pond wouldn't be picked up by a groundwater monitoring system, then you may want to consider adding additional groundwater monitoring wells or putting in a leak detection system. You have to look at sort of the cost benefit of putting in those wells and monitoring those wells versus the cost of putting in a leak detection system and then monitoring that leak detection system in the ponds. What mil thickness is typical for a pond liner? We typically have been using 60 mil HDPE for both the bottom and the top. But it is important to go ahead and put in that second layer of HDPE just to sort of give you that additional protection. What about air permits with the aerators? You would have to, depending on what aerators you got, you would have to consider that in your air permits. You would. If it's really just a bubbler, then you may not. But if it's sending the water very much in the air at all, it would probably at least be something you would want to consider adding to your landfill facility air permit. Now, it wouldn't require its own standalone air permit. What's the rationale for placing textured geomembrane over the smooth geomembrane? Simply because if it's at all wet, smooth geomembrane is really difficult to walk on. So it's a lot easier moving around those slopes if you got textured geomembrane. That's it in a nutshell. Would it make sense to include a sediment factor in the design calculation to avoid the need to remove sediment and dispose of it in the landfill, thereby increasing the strength of the leachate? It certainly could if you were particularly worried about it. My experience is that it's really has not been an issue. Like I said, this landfill has been operating in a location that is just rife to have sediment, and after 10 years, you know, they'd probably have a hard time filling a wheelbarrow full of the sediment that's in the bottom of those ponds. So it operates for another 10 years, which would be 20 years, and I think they're still going to be blowing, you know, an inch of sediment in that unless something really changes, which I just can't imagine what. So if you were in a situation where there was a real reason to worry about that, you could. But I don't know that I'd worry about that. That seems like a lot. And you know, when you do remove that sediment, you know, you're just going to be returning it to the landfill, and you're talking, you know, 1 or 2 cubic yards of basically soil. I don't think it's going to make have a big impact at all on the overall quality of the leachate in the landfill.
And we can wait a few more moments for any additional questions that people might have. Please feel free to put them in the chat box there. And Mr. Murray, if people wanted to contact you later on, how would they be able to do so?
You can contact me through my email address, which is jmurray, M-U-R-R-A-Y, at scsengineers.com. And that's the easy way, and I can get back to you on anything.
Perfect.
If you wanted to use just this, we use the 2 layers of geomembrane. The second geomembrane is technically our protective cover. So going with just a single geomembrane, you're much more likely to have an event where something falls on it and maybe it pokes a hole in there and maybe you don't know about it. At least for us, we felt more secure in having the 2 layers of geomembrane um, with the top layer acting as protective cover or protection for that second geomembrane that's laying in contact with the soil liner or on top of the leak detection system. But that's simply our rationale for doing it. Otherwise, yes, if you didn't think that you needed that second geomembrane, then yes, I would make that second. I would, if and I was going with a single geomembrane, then I would make it a textured geomembrane. No, there's no need for ballast on the bottom of the ponds. Um, I guess the assumption is that you're not going to be building these ponds down into groundwater. If you were to build these ponds, if you were to build these ponds to where you actually had groundwater acting on the bottom of the ponds, then you would require ballast. But my recommendation would be then that you pull the bottom of the ponds up and to where you don't have to put in ballast, because it just doesn't seem to make sense to dig your hole bigger so that you can go putting dirt back in the pond. So in this case, I mean, we've designed some of those ponds that I showed you were basically designed with almost no excavation in them. They're just totally on top of the ground ponds with embankments. Wouldn't the placement of the drainage layer underneath the second geomembrane prevent intimate contact between the geomembrane and the clay liner, therefore compromising its integrity? It certainly compromises its leak its leak prevention abilities, because when geomembrane liner is in direct contact with the clay liner, the combination of the two is much better than just the two if they're separated. So that is true. The issue becomes where do you put the leak detection layer? And in this case, it was primarily driven by a regulatory condition. The regulator basically required us to have the leak detection above the clay liner and not, we originally proposed it below the clay liner, but the regulator was concerned that if you got a leak, that you didn't have anything to contain it below that. So we made a concession and we moved it up there to between the clay liner and the lower geomembrane. But all things considered, my preference would probably be to put it underneath the clay liner, but just because you have a better system above it. But that's going to be something you'd have to work out with your regulators.
And it looks like there are additional questions coming in, so we can give people time.
No, is there a need for venting the liner system? No. Uh, haven't had a single issue with that. Um, because uh, you don't have any gas or anything like that that's coming up through there. And we certainly have those kind of issues when we're building temporary rundown channels off of landfills, and you're getting gas underneath it, and all of a sudden you've got a big bubble underneath your geomembrane line rundown channel, and so we do have to do the venting on that. But in this case, because it's built off of the landfill, and hopefully in an area where you don't have a lot of gas trying to get up through there, there hasn't been any need. We've we've seen no instances of gas or air, oxygen, or just floating of the liner. So no, there's no need to provide any venting. Thank you.
Okay. If people had any last minute questions, please feel free to type them in. We can give a moment.
Do these ponds generally require modifications to landfill permits? Yes. Yeah, they do. At least here in Texas. But it is, at least has been, although things change, it has been just a permit modification, um, and fairly simple. Um, Sometimes they'll require you get a state reviewer that'll say, I want to see calculations, and I'll say, well, I can do these calculations, but you also have to realize the site has 4 other things they can do with their leachate, which includes recirculation and hauling off-site to a POTW and whatever else. And so these complement on the facility's ability to handle leachate. And can I comment on winter operations in northern states with frozen surfaces? Unfortunately, no. I know you get evaporation off of frozen surfaces. I'm not by any means an expert on that, but I think that those numbers are reflected in the reduced net evaporation that you see on like this current slide as you get up into the parts of the country where it's typically colder and and not necessarily, especially like the upper Midwest, areas that aren't all that wet, but are very cold, their evaporation is down. So I think you probably don't get a lot of evaporation over the course of the winter. So that's where looking at your total sort of handling capacity and how you address that comes into play. And the only other thing is, and I can't really offer an opinion on it, but I did think about it, is what would be the effect, or what concerns do you have if you're up in some place where you've had a foot of leachate in the bottom of your pond and it freezes solid? Are there any concerns with respect to damaging the liner system? I really don't know. I don't have any expertise with that, but I would definitely think that would be something that you would want to consider, as that's why we have that second geomembrane liner on it, just to provide additional protection of it, especially in those cases where the pond might be frozen solid over the winter. And I also don't know, I'm sure the landfills continue to make leachate throughout the winter, so you're going to be having that continue to go into the ponds. Is it reduced any during the winter? I don't know. I would think to some extent it's probably reduced just because you have less rainfall percolating down there, but I'm sure that's pretty well buffered by the waste mass. So.
I don't see any other questions coming through at the moment. Um, so first, let me thank everyone for joining us on this call today, and thanks for all the wonderful questions. It seems like there's a lot of interest in this particular topic, which is great to see. And of course, most of all, I would like to thank our speaker today, J. Roy Murray. Thank you so much. Appreciate
Thank you.
it. I would like to wish everyone a great rest of the day and a wonderful rest of the week, and hope to see you on next week's Swana webinar. Bye-bye.